I'm Anil Kumar, and in this video we'll try to understand characteristics of a rational function. We have a question from the previous test paper. I'd like you to copy the question, answer, and then look into my suggestions. So the question here is, explain the characteristics of f of x equals to x cubed minus 7x minus 6 divided by x squared minus 1. Now, as you can see, we expect an oblique asymptote. Since the degree of numerator is higher, we expect two discontinuities, which could be vertical asymptotes or whole. Since the denominator is 0 for plus and minus 1, and we are not very sure of how many x-intercepts are there. So to find the x-intercepts, it is a good idea to factor the numerator. So let us factor the numerator, which is x cubed minus 7x minus 6. Let's begin from here. Okay. Now to factor this cubic equation, you could try to place numbers like plus minus 1, plus minus 2, plus minus 3, or plus minus 6. These could be possible factors. If you try minus 1, then you'll get a 0, right? So you'll find that we get a 0 for minus 1. So if I write minus 1 cube minus 7 times minus 1 minus 6, I do get minus 1 plus 7 minus 6, which is 0. That means that x plus 1 is a factor, right? Now if x plus 1 is a factor, then dividing this by x plus 1, I'll get quadratic equation. And once I have a quadratic equation, then we can find further factors, correct? So let us divide our equation by x plus 1. So we have x plus 1, and the equation is x cubed. Since there are no x squared terms, we'll put a placeholder here, minus 7x minus 6, and divide. So let's divide by x plus 1. So we get x squared here. So we get x cubed plus x squared. So when you take away, you get minus x squared. And this is minus 7x. That is minus x. So that gives you minus x squared minus x. And that should be minus 6x. And we have minus 6 here. So minus 6 times minus 6x minus 6 gives us a 0. So that means the other factor is x squared minus x minus 6, right? So we could write x cubed minus 7x minus 6 as equal to x plus 1 times x squared minus x minus 6, and this could be further factored, and we could write this as x plus 1 times 3 times 2 is 6, and 3 should be negative, so x minus 3 times x plus 2, right? So that is how we can actually factor the numerator, right? So let me rewrite the numerator as equal to x plus 1 times x minus 3 times x plus 2 divided by, denominator can be written as x plus 1 times x minus 1. You get an idea, right? Now from here we can cancel these, so that results in a whole, right? So we could write f of x as equal to x minus 3 times x plus 2 divided by x minus 1, where x is not equal to plus minus 1, correct? So that becomes our simplified form of the given rational expression, right? So from here we got one characteristic, that there is a whole at x equals to minus 1, correct? That's what we have got. Now we also understand that there is a asymptote. Since the degree is 1 higher for numerator, there's also oblique asymptote, right? So this is the numerator for us. If I divide x squared minus x 6 by x minus 1, we can get equation of oblique asymptote. So now we'll find oblique asymptote, right? That we can do by dividing this quotient, which is product of these two, right? So it is x squared minus x minus 6 by the denominator x minus 1, correct? This is expanded form of the factored form, right? So that gives us x times is x squared minus x, and that is remainder of minus 6. So basically what we find here is that we have an oblique asymptote, and the equation of oblique asymptote is indeed equals to y equals to x. So y equals to x is oblique asymptote. Correct? So that also we have found. So let us summarize what results we have already found, right? So now we can write down that we have a few characteristics. Let us list these characteristics on the right side. Starting from the very beginning, we find that we have a hole at x equals to minus 1, right? And then we have vertical asymptote. Let's say vertical asymptote at x equals to plus 1. Then we have oblique asymptote at y equals to x, that is the oblique asymptote. How about the x-intercepts? Now if you look at this equation, numerator will be 0 for x equals to 3 and minus 2. So we can write x-intercepts at x equals to 3 and at minus 2, correct? How about y-intercept? Y-intercept is when x is 0. So if I write x0 in this equation, let's use this equation, then minus 6 over minus 1, that is 6. So y-intercept is 6 minus 6 over minus 1. When you write here, okay, y-intercept is known to us. So we know the x-intercepts holds asymptotes. Now, if the hole is at minus 1, what is the value of the function? So we say f of minus 1, we'll substitute in this equation, will be minus 1 minus 3 times minus 1 plus 2 divided by minus 1 minus 1. And that gives you, this is minus 4 times 1 times minus 2. That gives us a value of 2. So we have a hole, and the y value here at hole will be y equals to 2. Is that okay? So we have a hole at minus 1 and 2. With all this information, we can actually sketch the graph and then write further characteristics of this function. So let me show you how. So what we will do here is we'll kind of sketch the graph. Let me do it right here in the center. So we are not going as per the scale since we have very limited space here. But what we find here is that we have a vertical asymptote at x equals to 1. So let me sketch this as vertical asymptote x equals to 1. Okay. And then we have oblique asymptote y equals to x. So this is the oblique asymptote, right? So this is the oblique asymptote. We'll say y equals to x. And this is x equals to 1. Now, the equation could also be written in the form as we saw here when we found the oblique asymptote. We got minus 6 here, right? So basically, what we could write this as, let me use this equation here. So we could write the function, let me write function f of x as also equal to, so if I divide this numerator by x minus x, we get x, right? So we get x minus 6 over x minus 1. So that is also a form of writing this equation. Since it is minus 6, if x is very large, we are approaching from underneath. X is positive, this value will be positive, right? So we are approaching this asymptote from underneath, right? But if x is negative large value, then this becomes positive. We are approaching kind of like this. So that's the end behavior for this particular asymptote. You can also find end behavior near the vertical asymptotes. So if you are approaching a value of x which is slightly more than 1, so this is positive, right? And this value, slightly more than 1, will give us a positive value here also. So we'll take away a bigger positive value, which is kind of -6. So that gives us a negative value here, right? So this is negative value. On the other hand, if I have a value x less than 1, you could use the factored form. You can find that this behavior is kind of like this. So for vertical asymptotes, that is a better equation to use. Anyway, all this concludes that the graph of the function could be given kind of like this, right? So this could be the graph of the function, right? So let me first sketch the graph, and then I'll place the other values. The other values which we have are, we know that the x and y intercepts are given to us. The y-intercept is at 6, right? 6. So this value here is 6. The x-intercepts are at 3 and -2. So this value is -2, and this value is 3 for us. Now from here, we can see so many other characteristics. So what we see is that the graph is positive during which interval? It is positive from -2 to, this is 1, right? So it is positive from -2 to 1, and also from 3 to infinity. It is negative from -infinity to 2 minus, and it's negative from 1 to 3, right? So that is where f of x is positive or negative. Now we can also see increasing and decreasing. So it is never decreasing. Do you see that? But it is increasing in the interval. Well, we have forgot about the whole. We had the whole at -1, 2. So -1, 2 will make a hole here. This line should have a hole here. So this is a hole for us. Let me write down here. Hole. And the coordinates are -1 and 2, right? So that should not be included. -1 should not be included in the interval of increasing, right? So it is positive from -2 to, I should write -1, and then from -1 to 1. So it should be -2 to -1, and then I should include from -1 to 1, right? That makes some sense. Okay. Now increasing interval is from -infinity to, there's a discontinuity here. That is why we are saying till -1, and then from -1 to the next discontinuity at 1, and then from 1 to infinity, right? So it is always increasing. We can also write it is never decreasing. Okay, so that summarizes all the characteristics of this particular rational function, which has an oblique asymptote y equals to x, right? Y equals to x. Vertical asymptote at x equals to 1, a whole at x equals to -1. And I hope you understand and appreciate different steps which we took in between to find all these characteristics and sketch our function. I'm Anil Kumar. You can always share and subscribe my videos to learn. Thank you and all the best.